All right, here's a related rates problem. The example says a ladder is 25 feet long, leans against a vertical wall. So let's draw our wall. There's our wall. And the ladder, which is right, let's make the ladder blue. Here's your ladder. The ladder is 25 feet long. If the lower end of the ladder is being moved away from the wall, so the lower end is going away from the wall at a rate of 6 feet per second, how fast is the height of the top decreasing? So that's here. This is dy dt, because we're going to call this y and we're going to call this x. So this is dx dt. Naming your variables is important in related rates. Dx dt is positive 6. Dy dt is what we're trying to find. It says how fast is it decreasing when the lower end is 7 feet from the wall. So 7 feet from the wall means x equals 7. This is the instant that we're going to try to determine what the rate of change is. So with related rate problems, we're always going to find formulas that we can use, and then we're going to implicitly differentiate, and then we're going to plug in what we know and then solve for what we don't know. So this is a pretty simple example. We know the equation that relates x and y together is x squared plus y squared equals 25 squared, the Pythagorean theorem. So if we differentiate implicitly with respect to time, so let me change colors here. We're going to take this and we're going to find d dt. How do x and y change with respect to time? That's why it's called related rates. You're going to see that. So we're going to do the chain rule: 2x times dx dt plus 2y times dy dt. And what's the derivative of any constant?
0.
0. So there's our equation.
Got it.
We know dx dt, that's 6. So plug in 6. We don't know dy dt, that's what we're trying to solve for. And we know at an instant, this instant, x is 7, and y, we can also find y because 7 squared plus y squared equals 25 squared. So use your calculator to determine what y is.
I should know that.
Or you can recognize that it's a family.
Yeah.
So y is 24. So we're plugging in these numbers. 2 times 7 times 6 plus 2 times 24 times, we'll call it m, because that's the variable we're trying to solve for. I don't want to call it x or y, because it's technically dy dt, equals 0. So solve for m.
Got it.
Subtract, divide. It's negative that divided by this. So let's just do this right here. M equals this thing, so let's cancel. What's this? 24 and 6, so there's 4, negative 7/4.
Yep.
And that's the right answer. That's how you
Excellent.
do that problem. So again, to review what we did, this is how related rate problems usually go. You try to draw a picture, use your information to come up with your variables and your constants. The variable, the rate of that. Anytime you see rate, that means that's one of your rates. And notice these are your two rates, dx dt and dy dt, because as the ladder is moving, as the bottom is moving to the right, the top is moving down. They're related to each other, and those are your two rates that are related to each other.
Got it.
So you plug in the stuff you know, you use your formulas to find other stuff and to solve for variables so that you can solve for the one unknown that you've got in your problem.